Okay, so in the last two videos we did a left-tailed test and a right-tailed test. Now we're going to look at two-tailed tests essentially. So researcher claims that based on the information obtained by the Center for Disease Control and Prevention, 17% of the people, young people ages 2 to 19 are obese. To test this claim, she randomly selected 200 New Hampshire youth ages 2 to 19 and found that 42 were obese at alpha 5.05. Is there enough evidence to reject the claim for New Hampshire youth? Okay, so either it is or it is not the national average is what we're trying to say essentially, right? So let's go back and copy step one here. One thing I should mention is some books do 4 steps, some books do 5 steps. So I'm sorry, some books do 4 steps, some books do 5 steps, some books do 6 steps. It just all depends how they break it down. But it ends up being the same conclusion and the same stuff. It's just how they break out the steps essentially. I like breaking out into a 4-step system basically, where it's basically what are you doing? Can you do it? Do it and then analyze it. And that's the way I like to break it down essentially, which is why I do it in 4 steps, whereas other books might do it in more or less steps. Okay, so this is a proportion of, we're going to delete this, people, young people. I don't know if we need the word young to be honest. 2 to 19 years of age that are obese. Okay. Okay. What's the, so what is it? So we delete this. And we can just pretty much take that again, can't we? Copy, paste. Okay, so looking at these young people basically, what proportion are obese? What percentage? Okay, so the national average says 17, right? And we believe it's not equal to 17 in New Hampshire, correct? That's all. So basically, what are we doing? Right, and this is what we're doing essentially. And I state our hypotheses. Step 2. Can we do it and what do we have essentially? Outline the parameters. So we have 100 people we sampled in New Hampshire, right? So it's 60%. Oh, shoot. That's 60%, not 60%, 17%. That would be 34, right? Double it. No, because 200 in the sample, right? 200. Yeah, 200 in the sample. Excuse me, 200 in the sample. That'd be 34. 200 in the sample, so that would be 83, right? So you double that, you get 166. Okay. So this would have to be 17 to match the national, and this would be 1783 over that for standard error. Okay. So I think we're good there. So what are we doing? Can we do it? Yes, those are both more than 10, and there's the parameters of what we're doing. All right, step 3. Actually do it. Okay, so the proportion that we found of the New Hampshire kids was 42 kids were obese, right? So that's 0.21, right? So 0.21 from the 17. So this is 17 and 83. So 21 minus 17 is clearly a positive number, right? So I'm going to get 1.5059 ... There's no more numbers after that, but it really doesn't matter, correct? So now what I need to do is actually 2 times this answer. And you're like, well, why is that exactly? What's going on? What are you talking about? Why is it 2 times this answer? Okay, well, let's take a look here. All right. Let's draw the picture. Okay, so we believe that this is P equals 0.17, right? And we're saying that alpha is 5%. That's what we're saying for this problem, correct? So that means this is 0.95. And it's a two-tailed test, which means we have a tail here and a tail here. So this is 0.025, and this is 0.025, right? For this area over here. These are the critical regions which we're going to cross, right? So we're either going to cross on one of two sides. This critical region, which is a positive one, right? It's a positive z critical. Or it's going to be a negative z critical, essentially, right? Because this is half of alpha, and this is half of alpha. Correct? All right, so when I calculated my z, the question is, where does it end up? So I had a positive z of 1.5. So is that z critical here, or is it here? That's the question. So is my z stat here, or is my z stat here? It's on this end because I had a positive 1.5. So either I have enough evidence or I don't have enough evidence. So my sample is either normal, expected, and I don't have enough evidence, or it made it to this region. Okay, so 1.5, so it's definitely on the right-hand side. Okay, so let's take this, copy, paste. Okay, so the question is the z-stat first. So we have the 0.21 minus 0.17 divided by the square root of 0.17 times 0.83 divided by 200. Okay, and there's the 1.5 that we had gotten. So the z crit we got to figure out now. So if I think about my picture here, right? This is 0.95, right? And we have two tails over here, correct? So we need to get to this z critical right here. That's the z critical we need to get to. So to get from here to here, right? If alpha is 5%, this is 2.5%, correct? So 2.5 plus 95 is 97.5, correct? So normal dot inverse 0.975, comma 0, comma 1. So essentially what we really have is the actual versus theoretical, right? So the actual and the theoretical are two different things. So this one didn't actually make it to there, essentially. So if we do this, this is 1 minus the normal dot distribution of this z value, comma 0, comma 1, comma true, right? And I get this here, which is not the correct area. So if we think about this so far, right? 0.95, we have a z critical here, and we have a z critical here, and this area right here is 0.025. Okay. All right, so if we look at our spreadsheet here, our z critical is 1.95. So this is 1.95. Okay. And our z stat is 1.5, right? So we're actually over here somewhere. Okay, so this is z stat. This is 1.5, which means we did not make it to the critical region. We did not make it to the critical region, which means this is a very expected sample that's in the normal region. So we did not find enough evidence, basically, right? So we look at our area, what did we get? We got 0.06, right? So 0.06 something, basically, right? Okay, so did I do the correct math? So I did 1 minus, so I can get the stuff this way, correct? Right, so if I look at my spreadsheet here, did I do the correct thing? So area, 1 minus this z value. So that means I'm going above it essentially, right? So, right, so essentially what I'm doing is I'm going, right, so I have this z right here, 1.5. So this function gives me this area. So if I do 1 minus, it goes to this area here, correct? Okay, here's the problem though. I need to do parentheses around this. Actually, no, let's do this. So I get a p-value equals to 2 times that area. Ah, no. Clicked on the wrong thing. 2 times that area. Okay, so that's what it really is. Because essentially what you have to remind yourselves is, okay, I have a z critical here. I have a z critical here. Right? So when I calculate z stat, that z stat, that's only half the area, right? That z stat is only half the area, which we got what? We got 0.06. So this is 0.066, right? So I have to double that because there's another one over here of 0.066, right? So those together are the p-value essentially. Okay. All right, so let's go to here. So I'm going to do 1 minus, put parentheses around that, and I get 0. Crap, I already forgot the number. 1320. Dot dot dot. Okay. Hopefully I gave you all the correct numbers. All right, step 4. All right, so the p-value is 132 dot dot dot, correct? Yes. The alpha is still 5. Let's go back up. Alpha is 5. So this is definitely, oh, sorry, 1320. Got that wrong. That is definitely more than the alpha. So thus, do not reject the null hypothesis, right? Essentially, we were not in the shaded region, right? The p-value is not low, so the null must not go, okay? If the p-value is low, then the null must go. So our sample proportion is not significant, so our sample is not significant, and it's likely to occur. So that's a common sample. There is not enough evidence to reject the null hypothesis. We did not find enough evidence to say what? New Hampshire kids are more obese than the national, are not more, our kids have a different obesity, right? Correct? Is that the correct wordage here? Obesity rate than the national average. Can't type here. Okay. We do not find significant evidence to say that New Hampshire kids have a different obesity rate than the national average, right? So we have to accept the national average unless we find evidence, which we did not. So a two-tailed test doesn't tell us whether the kids are more or less fat if we prove it. We just know that it's different essentially. So that's a two-tailed test.